simplification, and we moved on to talk about international cooperation at large, which seems to be rather, if we look at the signing of the Kyoto Protocol, the predecessor to the Paris Agreement. However, this wide participation is actually only the counterpart of a not so wide commitment in terms of greenhouse gas emission reductions. In the end, it is mostly countries in the EU area that committed to reducing below business as usual, especially if we consider that there was some backtracking in North America. So that's the other way to summarize the tendency in terms of greenhouse gas emissions. CO2 concentrations have been on the rise. If we continue a few years further past 2010, we would see that we've even passed the critical, at least psychologically important threshold of 400 parts per million of CO2 in the atmosphere. So this is more or less the end of last week's part, after which we played together, at least with those that were present online or in Rimini last Tuesday, some of the games that we will be analyzing more theoretically today. And then in the second part of the lecture, we will have the first two presentations, first three, actually, I think, all three papers are scheduled. And if we have time, we will continue with MobLab and the interactive online sessions. So let's go back to the prisoner's dilemma that we've already encountered, including its N-person version. And this time we will try to see to what extent this is a good indicator of strategic incentives in games of climate change negotiation. So try to scale up from these small, simple games, even in the simplest form, 2x2 experiments, to the global scale. So that's the first bit of games we will encounter, and then as you see here in the outline, we will talk more specifically about common pool resource situations such as fisher games, which again, if we have time, we will play one ourselves later on today, if not tomorrow. When we talk about public goods, of course, since we're all interested in environmental problems and climate change economics, that comes to mind, but you can think about related type of public goods that require widespread cooperation in order to be provided, such as knowledge, a lighthouse indicating the way, national security, but also if you think about, for instance, the many flood control systems that have spread it around Europe and elsewhere, these can be thought of public goods. So to stay in Italy, we have the MOSE, I don't know in English how you call it, project to keep the lagoon safe or relatively sheltered from seawater rise. We have an even more ambitious flood control system up in place in London, which is actually an interesting approach because it has been built in a modular way in order to be able to respond to increasing levels of sea rise over time. So that's a tense barrier. And other examples range from street lighting to the mitigation of greenhouse gases. So another look at the strategic aspects that define a public good is a good that is both non-excludable, right? You cannot exclude anyone else from consumption, and non-rivalrous. Use of the benefit by one individual does not diminish its availability to another. As we have already mentioned, the PD, or prisoner's dilemma, captures this most simple form in 2x2 situations where there's only two players and the action space is limited to two strategies, but you can make it more complex with more players and more actions. The n-person prisoner's dilemma constitutes the most used metaphor to study public goods games. This, right, in which we have this trade-off tendency between self and societal interest. Unlike the other class of very important games for environmental problems, and not only, namely coordination, meaning that there's more than one equilibrium, unlike in the PGG, right? We know that the only equilibrium that is in principle stable if you have own regarding preferences in the PD or public goods game is to defect for all, but in coordination game you also have a better equilibrium. Then the choice or the dilemma then is in those games to coordinate on the better one. But here we are in an even worse situation from the point of view of the evolution of cooperation, because selfishness would lead you to the bad outcome. To look with a bit of more rigor at the payoffs and the incentives in this game, called C, the contribution that is paid by cooperators. Defectors simply free ride, right? So they do not have to pay for that bus or for the lighting in the street or for greenhouse gas mitigation. So there's no contribution for them. All contributions by cooperators then are summed up, multiplied by a reward factor, often assumed to be 2 or 1.5, whatever is produced or put in the pot. And that's a factor R for reward, and then it gets distributed to everyone, including to the defectors. Right? That's why they can get a free ride on the effort of the cooperators. So this is the payoff to the raw player, player 1. Right? So the guy here on this side, by either cooperating or defecting, it drives even more clearly, I think, than the way we have seen it in an earlier lecture, the tendency to defect, because from the perspective of player 1, it's always dominated the choice to cooperate, because you always have to pay that minus C cost, and you could do better individually by doing defect and secure B here, or not pay any cost in spite of both players defecting in the other situation. That's why defecting is the dominant strategy. So call I the number of cooperators, so there are n minus I defectors, since n is the total number of players. In the games that we have played, we had n equal to 4. In the public goods game, the payoff to defectors and cooperators is simply this one, so the reward times the number of cooperators split by the number of players, and we see that this is equivalent to the cooperators payoff, except that, as we have seen also comparing these two rows, that the cooperator always has to take away that C cost. So the payoff to the cooperator is just the payoff to the defector, which is a function, of course, of the number of cooperators minus the cost. Everything clear so far? Any comments? Questions? Okay, so this is the basic theory. By now, I think we are all familiar with it. Let's see how good of a job it does in highlighting some of the important trade-offs that we are faced when we conceive of climate change cooperation. So in the public goods game, collective action is required to provide the good, right? Even if you have one or two, say in a group of 4, one or two stubborn cooperators, it's not going to be enough. Otherwise, we wouldn't have a dilemma in the first place. We need widespread collective action, almost universal cooperation, or by a majority of individuals. Defectors get the same benefit of the cooperators at no cost. That is inherent in those payoffs that I've showed you in the previous slide. Hence, defecting is the dominant strategy. What about climate change? So, for what concerns mitigation of greenhouse gas emissions, solving the global problem unilaterally is clearly not a viable option, right? Even if you are a very wide country or even a bloc of countries, say the European Union, that's insufficient to get to any reasonable level of warming. A country that reduces emissions bears the full cost of reduction, but gains a fraction of the benefits. If all other countries cooperate and reduce emissions, it actually pays to free ride on their efforts, right? You are in a situation where you get mitigated climate change and can take a back seat. Another aspect that is not captured well by the standard linear public goods game is the presence of thresholds, which is why we are interested also in the more applied MobLab sessions to play these threshold public goods games. And from a strategic point of view, they're important, this class of game, because in principle, so long as the threshold is known to everyone and it's salient, they may help cooperation because they may make it focal to just get to the level I think in the MobLab game it was set at 50%, right? So in a way, it makes it salient that you have to invest on average half of your endowment. So more in game theoretic terms, that means transforming the game back from a PD type of game with a dominant strategy to defect to a coordination game where you have the possibility to, in this case, coordinate on the threshold. Again, how easy it is to coordinate, especially, say, if you do not have communication mechanisms, that you may still fail, miscoordinate. There's still the tendency or the incentive for someone in the end to free ride. That's why we play it both without communication and with communication. But it is a simpler game to solve. In climate change terms, that would mean that globally everyone is on board, there's no longer widespread skepticism, public attitudes are aligned, so people demand strongly action on climate change, and we know that to get to, say, 2 degrees Celsius warming, we need to do X amount of mitigation. We're clearly not there yet, but the hope is that we transition towards this equilibrium. Comments? Okay. So let's talk about CPR, or Common Pool Resources, quickly, because we will be interested in seeing them, how they've been played, and also in playing them ourselves to see the theory at work. Again, here we have many examples. I've chosen many to be somewhat related to environmental problems, but you can also think about non-environmental problems. Probably the most common one is fisheries, and we will be seeing such gains. But you can, so that in this case, the harvesting pressure, right? How many vessels do you send out to the ocean is what imposes a pressure on a resource that may face stock declines above a certain level of activity. But the same goes for forest management and logging of trees. There's a reproduction rate. If you push it too hard, there's simply not enough reproduction going on in order to sustain that pressure. The same, to some extent, goes for extraction of minerals, investment in irrigation. We have seen the water temples in Bali earlier in this lecture slides as an example of a common pool resource that was functioning and was destabilized by human intervention. Taking water from basins underground, and again, you can also think about unpolluted air, for instance, locally in a city, in Rimini or in Beijing, as a common pool resource situation. Again, the tendency from the individual perspective is to put that one extra chimney or extra car so that eventually you get to the state that is uninhabitable and citizens may be forced to leave town, if we go back to the framework we saw in the earlier lectures. So this is just a summary, right, that we should be familiar with, all of these characteristics of excludability and subtractability. And again, this is rather stark, but you can have hybrid situations. That's what we call, for instance, club goods where there's no element of rivalry, but they are excludable. Or today, or in this part of the lecture, we're focusing about those that are not excludable, but rivalrous. That's a common pool resource. Why is there rivalry? Because the more fish one of us takes, the fewer there is for the others to take. Yet you cannot exclude, right? You cannot put nets around a part of the lake or the ocean. In principle, there's also management ways to try and counter this, but in the standard open access commons, you cannot exclude other fishermen to go on the lake and increase activity. So I've talked about fisheries. This is the pasture way, right? Where if you are the individual farmer, for you to add one more cow to do the grazing on the common land, that you have an incentive to do that, but there may be a threshold or a tipping point, to use a term that we have encountered many times. Say in this case, for this type of ecosystem, it is just 20 cows. Above that, grass does not reproduce fast enough. That's one interpretation. The other one, that of this tragedy of the commons, that was pushed forward by Gareth Hardin in the 60s in this very influential, if not controversial, science article, is that you can think about numerous environmental problems, including greenhouse gas regulation, right? Usual story here, and maybe there's a threshold, hopefully quite a bit above 400 parts per million, because we're already there, above which disasters ensue or runaway global warming may take place. Why is it controversial, in my opinion? Well, not just my opinion, but there's a big literature that criticizes this tragedy of the commons framework that was so influential, also because it's such a clear and neat story to tell. But it is a specific story that may not apply in many situations. So the idea of the tragedy of the commons is that we have this trade-off, right, between individual gain and collective good. That's from the farmer's perspective, right? You want to put more cows on the grazing land. And what Hardin concluded is that in such situation, the only way out is mutually agreed upon coercion. So either some kind of police, right? If it is the climate, then we will need some kind of overarching international agency that has power to punish the deviators, the defector states, or we come to an agreement ourselves, and what is seen by Hardin as the key solution here would be privatization. So these commons need either to be sold off so that we can establish property rights, or there needs to be regulation, some kind of control. That's what I meant by the climate police before. But this is true for some domains, but not all situations, as Lynn Ostrom and others have documented in the field. Not all commons are facing such dire conditions for the evolution of cooperation. For instance, an important assumption for the tragedy of the common to ensue is that of open access, right? That we cannot put any limit on the water pumped out of the basin, or the amount of forest being logged, or the number of vessels that go out to fish. But we know that in reality, maybe through social norms or other mechanisms, there are institutions that somehow control access to the shared resource. So that's the second bullet point, the fact that in reality many of these commons are managed more or less formally. And here Hardin assumed no norms of sustainable extraction, and neither institutions, formal institutions. Also the absence of communication, so maybe that works in a very atomistic and globalized market where people interact online, but in smaller groups in the field, there tends to be quite a bit of communication. and not just communication, but also reprimanda and spiteful behavior should people be observed to violate the social norms, including channels such as gossiping and informal or more formal punishment, and also the standard assumption of selfishness and myopia in the sense of maximizing only short-term returns. So let's, unless there are questions, let's have a look at what is also called Pac-Man game, simply because it looks a bit like a game of Pac-Man, but this was done with students, and they were tasked. You see in this game we have five avatars with different numbers from 1 to 5, and you can think of these as fish or trees, and so you could harvest these tokens, these diamonds, by simply clicking on them or moving your cursor so that your avatar would be above the diamond. And so we will see, hopefully, if I'm able to play the video, how these different groups play different treatments. Here the two treatments are very simple, with or without communication. So before we do that, this is a stylized representation of what could happen over time in two types of groups. One composed of myopic, selfish agents, so they're just running to the resource, moving their cursor as fast as possible, because if they don't do it, they fear that the others will do, and then they exhaust the resource quickly, and there's no reproduction anymore. Here we have a situation in which there's some kind of emergent norm where participants, self-imposed limit on the number of clicks, so that they would see some of these diamonds reappearing before harvesting again. But the question is, how was it played in practice? Can you hear me at the back, or do you need the microphone? You hear well, yeah. Okay, so let's have a look at the video. Okay, so this is the version without communication. What? Okay, let's see. So they start with a lot of, with a lot of tokens, as you'd imagine, and you notice that sometimes they reappear. So the students were aware of this reproduction rate and the fact that waiting a bit would suffice, but clearly they don't seem to be waiting much. And maybe there's some kind of contagious dynamics with maybe one of these 5 avatars would have been more willing to wait, but seeing that everyone else seems to be rushing. Maybe 2 seems to be more patient, but in the end, she goes for it because things are not going in the right direction. And you can see that I think they had 5 minutes in each round to decide on resource, and here after just about 1 minute they're out of resource, and they're just staring at the blank screen for 4 minutes because there was definitely a tragedy of the commons, and you see nothing appears back, right? We've taken out all the fish from the resource. Let's see if I can find the one with communication. No, this is again. Before. Okay, well, maybe during the break I try to find the other one, because for some reason it's not showing to me. We'll see how they played once, and when I say once, I actually mean it's different groups, right? Because as you know, you gain experience, so of course the same group would have played differently the second time. We'll see how they did when a separate group of people played with communication. Okay, I have another video that we found, and it's not with humans, so you can also do experiments with animals. In this case, capuchin monkeys. They are highly sociable and intelligent animals, and we will use their version of a dictator game to look at equity concerns and preferences for fairness, and why such games may capture important aspects also among humans. So let's see if this one loads. Okay, I don't know if the audio will work. In case not, anyways, let me just tell you what is going to happen. So you see there are two monkeys in cubicles or partition cages. They're made in such a way that each of them can see what's going on also with respect to the other monkey. The experimenter has trained them to give a rock to them when she asks with the hand for the rock. So the task is to return the rock, and there's a compensation here. She has two, you don't see it now, but she has two baskets. One is filled with cucumber, which is an okay reward, not bad, but not very sweet. The other one is grapes, that is much preferred. So you can imagine that, where this is going. So there's going to be unequal rewards for the same activity, because both of the monkeys do the same thing with the rock giving. And one, I think the one on the left, is compensated with cucumber, the other one with grapes. So there's an element of justice here. Let's see. Okay, so I think you get the point. This was an experiment done by a sociologist, Franz Derval, about moral behavior in animals. So the first time the cucumber was acceptable for the monkey on the left, but it becomes problematic when she sees that it's a different reward than the other one gets for the same task. So how do you capture these trade-offs? This one is a slightly more complex version that is typically played with humans instead, but the underlying idea is very similar. It's an ultimatum game. So in this particular version, which is not the standard one we have already encountered, there were 4 treatments to this game: the 5-5 game, the 2-8 game, the 8-2 game, and the 10-0 game. So the only difference here, because you can see that the payoffs are identical in many branches, but what differed is only what happened here, in case basically the proponent, the first mover, goes right, chooses action Y, right? Because if you go left, if the proponent decides to go this way, you see there's no difference among the different treatments. But in the 5-5 game, the alternative to the selfish, so why is this the selfish choice? As you will remember, in this case, that leads to an 80% to the first mover and a 20% to the second mover, right? So it is rather skewed to the advantage of the proponent. But the proponent has an option. He can choose to go in the other direction, in which case would mean giving a 50-50 split. So in this case, both would go home with €5, say, if they were given 10. The 2-8 game is actually more challenging and even more altruistic choice from the proponent's point of view if he goes this way, because that means giving the advantage to the second mover, right? So there's a very stark difference between this and this, and remember that the bargaining advantage is with the first mover, so it's in a way it's more unlikely that he would pick this very altruistic choice. Remember that in order to have the resource being shared according to this 8-2 or 5-5 or 8-2 and 2-8 split, the respondent has to accept, right? So it's an ultimatum game, but unlike the dictator game, the respondent does have a say in whether the deal will go through. So in fact, we're very much interested in what the second mover would do, depending on the treatment played. Now, the 8-2 game is really a game where the proponent has no choice, because whether he goes this way or this way, the split is always unequally split, with 80% going to the proponent. And this is the 10-0 game is actually even more extreme, in the sense that actually the generous thing to do from the proponent's perspective is to go this way, because if he were to pick action Y, that would lead to 100% going to self, right? So in this case, you'd, let me ask you, so what, given these payoffs, in which treatment would you expect the second mover, the respondent, to reject the move to the right the most? Any ideas? So let's put ourselves in the shoes of the respondent, whether the responder accepts or rejects. That's the only option that the respondent has. So do you think, for instance, comparing the 5-5 game and the 10-0 game, do you think which one of the two treatments elicits the highest rejection rate, where the one where most second movers decide to reject and choose the 0-0 choice option between 5-5 and 10-0 game?
I would say the 10-0 game.
In the 10-0 game, you expect more or less rejections, or more rejections?
From the respondent.
Note that the respondent basically, okay, that's interesting, because you're saying,
I mean, in both cases, its payoff is 0, so maybe you could say, okay, if I'm not getting nothing, you're going to get nothing too. Otherwise, the payoff would be 0, and the first player would get 10.
okay, so maybe I wasn't clear about the way I formulated. What I mean is, assume that the proponent goes this way.
Sorry.
Will where would we get the most rejections? Because going right here is a selfish move, right, from the point of view of the proponent. Going right here is also, would be the general thing, right? So I would expect that remember the outraged monkey? So the idea here is that people seem, including monkeys or capuchin monkeys, seem to not only evaluate the 0 payoff, that's a sort of standard, my utility equals to just utility of X on payoff, but they evaluate also the alternatives, because this is common knowledge, right? So the respondent knows what it means to go left or right in each treatment. So, like the capuchin monkeys, we look at what happens, what the alternative way could have been. So let's have a look. This is the rejection rate by the respondent in the different games. So here, in the 5-5 game, doing the selfish thing, going to the 8-2 split, is arguably the most selfish gesture, because you had an alternative which was to split 50-50, and you chose not to. And that is definitely the one eliciting the most rejection. That's an important observation, and I think if you think about it, it makes sense, you know. Like, take this one. In this 8-2 game, actually the proponent has no choice. Left or right, it's always 80 euros to proponent, 2 euros to the respondent. So in fact, I would have expected 0 rejection here, because what could the proponent do? The 10-0 is even more extreme, because actually by going left, he was doing a more generous thing than going right. Yet there's still some rejection, maybe out of frustration, right? So there's complex thinking going on here, and maybe some errors or noise, but the order makes sense to me. There's the most rejection when the alternative would have been fair and you chose not to take the fair. When I say fair, I mean 50-50. Here also makes sense, but it makes sense that it is less. Another observation, though, is that people seem to, again, and something that we have encountered before, seem to have both preferences for equity and distribution, but they're not fully, they're also somewhat selfish in the sense that they care about own payoff, because even in these very unfair situations in which the proponent chose to go left when he could have split equally, most people, 55%, chose not to reject. So there seem to be half that are morally motivated and outraged, like the monkey that decides not to take a reward that is of value, even if of lesser value than the grapes. So here we have about half, almost half doing that, but just about 50% actually accepting the sour cucumber.
Sorry, maybe there is like a negative utility when it comes to the 5-5A. Is that the case?
How do you mean? Can you elaborate?
For a matter of fairness, let's say, consider that we can split in 2 equal parts. I prefer to get nothing because otherwise I will have a negative utility.
Yeah, probably, yeah. I mean, again, it's not compatible with the standard selfish model, but if you have, say, inequality aversion, we have seen it, no, where you look at the difference between your payoff, X, and the payoff of the other, Y. So in this case, if you have enough disadvantageous inequality aversion, meaning that you suffer enough from the fact that you're worse off than the other, and you are worse off than the other in this setup, right? Because your payoff could have been 5, instead is 2 from the respondent's point of view, and 2. So you compare 2 to 8, right? With the weight that is large enough, you can definitely be better off choosing reject. So this choice is compatible with the model, but not with the standard model, because if your utility only depends on your own payoff, 2 is better than 0, right? But this is a bit like the monkey saying, no, I'd rather not have that cucumber. I'm outraged. That's ideal. So yeah. Any other comments? Okay, so of course these kind of trade-offs and reasoning apply to situations that are also at the global scale, including how to split the burden of mitigating climate change, right? So if we look at the environmental commons, or for more local commons, how to find a way to self-impose restrictions so that we do not end up in the tragedy of the commons, where we overfish in the lake, or we overgraze the land, or we lock down too many trees. A related concept that comes more from the natural sciences and is related to the adoption of different behaviors is, and possibly that may help in the transition away from a prisoner's dilemma, so escaping that negative outcome, has been introduced by Bass also in the late 60s, which is why it's called the Bass model. And it is a simple idea of an S-shaped diffusion curve, where over time and proportionally to the fraction of adopters of that good or technology or behavior, due to these spillover effects and positive externalities, say usage of mobile phone or smartphone, which of course is a function of how many others have adopted, it gets to, after an initial phase of slow uptake, we've talked about electric vehicle uptake, for instance, you get to a phase where the pace gets increasingly rapid until you saturate the market as you approach completion and full adoption. It has been empirically tested on many different behaviors and including fashions, and there's quite a bit of empirical evidence backing, for instance, adoption of hybrid corn seeds in the US and also behaviors. So the idea is that we have an adoption threshold, which is a positive function of the number of other adopters. It could be for convenience. We've talked about the fact that the more people, say, buy electric cars, the more easy it will be to find chargers. And that idea also that diffusion of such innovations behaves like epidemics. And finally, mutually reinforcing choices lead to accelerating diffusion once a critical threshold has been reached. So let's look at these ideas of tipping in the context of unleaded gasoline adoption and greenhouse gas emissions. So here the evidence is more illustrative, but for what concerns the switch away from leaded gasoline for fueling combustion engine cars, we see that there was a key role of early adopters in triggering a global shift from damaging pollutants to greener alternatives. So, for instance, this one for unleaded gas was triggered by a unilateral decision by a large actor in the market, the US, which forced basically others to follow suit. How did that happen? By the US adopting, it reduced the adoption cost for others to modify the refinery capacity. That's one driver, but another very important driver is that if you're, say, Toyota and you're exporting to the US, you have a big incentive to also modify your refinery capacity so that you introduce models that run on lead-free petrol. So they followed up the lead quickly after, so that they were able to export to the US. And that meant reduced costs for the followers, and hence the innovation spiraled quickly to the rest of the world. So if you're interested in this specific example, there's a nice paper by Heel and Kunreuther from 2012 that looks at that. So again, this resonates with what we have said before about CG, coordination games, versus PD, prisoner's dilemma games. Thresholds have a potential to catalyze cooperation by transforming these games into ones that are solvable or more easily solvable. A similar dynamic took place when we were dealing with another environmental looming threat, that of the ozone layer, the expansion of the ozone layer, which became a big problem in the 80s of the last century. Again, here there was one actor, the US, that changed attitude and decided to sign the Montreal Protocol, which is often cited as an example of successful negotiation or international environmental agreement, much more successful than negotiations on climate change as have been. And again, this is probably due to strategic reasons. Here we are facing a situation of increasing differences where if one takes the lead, others have an incentive to also go in the same direction. So here the historical accident, so to speak, was a technological innovation by DuPont in the US, which allowed for the largest world producer of CFC, things like chlorofluorocarbons that are deleterious for the environment and especially for the They are of empirical relevance. So let's talk about such coordination games and see if we can identify tipping points and whether they can shed light for tipping climate cooperation. So we will talk about two related experiments that build on the same framework. So it's good to pay attention at this setup because the next one is going to be more or less similar. So unlike in the games that we have considered in class before or that we even played, they tended to be of the one-shot kind, right? Even the ones we played over 10 rounds, especially for the linear public goods game, you add a new endowment in each round, and we're tasked to allocate them between the public good or the private good. So here instead it is a different type of repeated game where it only matters whether you have reached the threshold at the very end, right? There's again going to be 10 rounds. It was done with more players to allow for treatments that varied the degree of wealth that players had. And they were given a total endowment of 40 to allocate over the 10 rounds of play. In each round, each player, remember there are 6 of them, can choose the selfish action, 0, what one can think of as the fair amount, 2, or 4, which would be quite altruistic and generous. Why do I say fair? Because here the threshold is set at 120. Given that you have 6 players, each with 40 euros, that's 240 euros in total. So if each player gives 2 over 10 rounds, that's 20 euros, that's half of the endowment for each player, and that's on average just enough to get to the threshold. So the group as a whole, the group of 6 players, by sacrificing or investing half of the total endowment, so if each of them gives on average 2, meaning that if the entire group gives on average 120, they avoid the dangerous climate change in this simulated game. Note that unlike in many games that are played with students, this one was actually framed, so it was, to make it more salient and clear, it was explained that this was about climate change mitigation. In fact, the money that was put in the public pot was used to then sequester or buy CO2 offsets. So it had also this public good nature in the real world to maximize external validity. So the idea here is that if the sum of the contributions over all 10 rounds is greater or equal than the threshold, you do not have any probabilistic component. There's you are in safe territory, so to speak, and each player goes home with whatever is left in the private account. If instead the sum of contributions is below the threshold, irrespective of how close or how far you are to 120, there's a probabilistic or a deterministic laws that we will go into that have to do with the idea that you're facing dangerous climate change or simulated dangerous climate change. Because it's a threshold public goods game, it's not a linear public goods game, there are also Nash equilibria that entail coordination. Of course, you can coordinate in many different ways, right? You can imagine that 3 players out of the 6 do the Nash, the selfish Nash, and always play 0. But the other 3 compensate in each round by giving 4 euros. That is quite extreme, right? 3 stubborn free riders, 3 stubborn cooperators, very altruistic. Why is it extreme? Because especially for those giving 4 each round, they would exhaust all the 40 euros. So in the end, they go home without any income. So that's unlikely to happen. But this is to say that, there's one clearly salient, at least under symmetric wealth equilibrium, which is to give, everyone gives 2, and you get there. So that is the symmetric Nash equilibrium. But there are also asymmetric Nash equilibria in which any trajectory that is compatible with getting to 120, whichever way you split it, say in this case that I mentioned, 3 giving 0 and 3 giving 4 each time, is also a Nash equilibrium, including a situation in which, say, for the first 5 rounds, all 6 players give 0, and then they wake up, and in the last 5 rounds, all 6 give 4 every round. On average, they will have given, in the end, the same as in the symmetric one, because they go home with 120, but they have managed to catch up, right, in the end. Of course, that's a risky business, we will see, because maybe if someone changes their mind or there's some error, in the end, you may miscoordinate. So probably easier to start off early. Any questions on the payoffs or anything so far? Okay, so change, or actually there isn't climate change. So even if you do not reach the target investment, say the EU target for decarbonization, no problem, 90% of the chance you will be doing well. So actually, from an economic point of view, if you do the math, you're better off not investing in this one. So it shouldn't be a surprise that no one protected. In fact, this is a borderline situation because it's 50% probability and you're pretty much indifferent. And you see that most chose the selfish equilibrium. Note that there's 2 types of risk here. One is the actual risk of losing the money if you do not get to the threshold. But when contemplating which equilibrium to go for, whether to invest or not, in a way it's safer, or you can free yourself from the choice of others by being the defector, right? Because then you know what's happening, you're not putting your contributions at risk. But if you cooperate, if you put those 4 euros, for instance, or even 2, and the other doesn't cooperate, or the rest of the group free rides, then you are particularly worse off. So that's a different type of risk, if you may. All clear so far?
You share the theory is losing the money.
Sorry?
Your risks, you say, losing the money, and the second one?
The second one is, you can think of it as the risk of being the sucker. So remember the choice between 0, 2, and 4. So let's say that you want to compensate because you notice there's some free riding going on, so you give 4 in a few rounds at the end. If the others are too selfish, you may still miss the threshold. Then that's the worst possible situation, right? Because you have being very altruistic and you still miss the threshold, so you have a very small amount of money left in your private account and a very high probability that this will disappear. So it's a risk of being exploited by others. So it's more about social coordination than about objective risk. The only objective risk is that P that is manipulated in these 3 treatments. But one possible reason why people may be reluctant to be generous, especially if we are conditional cooperators that are more inclined to cooperate if others do, is that you don't want to be the one that is exploited by others. That's why I say that there's some risk in doing the generous choice, because your payoff will be better provided that also the others do their part, but if they don't, it won't. Okay, so that's the Milinski game. Another way to visualize how frustratingly poor they were, these students, at coordinating. This is average, of course, over different groups playing these treatments. But if you look at, so this is the symmetric Nash equilibrium, where in each round they would theoretically give 2 per person, or 12 per group in each round. You see that especially the 90% treatment, which is the only one that really makes sense to contribute in, was very close. They started off just below on average. Maybe they started off at 2, but soon they were, you know, just a few euros below the trajectories that would have been sufficient, but they still had time to get there if someone compensated, but there seemed to have been, on average, a reluctance to do that generous act. That's why I'm saying that maybe that played into this as well, the fear of being taken advantage by the others. And then in the end, on average, they got to just below 120. Remember that this is without rebate, as we saw in MobLab last Tuesday. The rebate is whether you get your money back or not if the project is not implemented. In this game, you know, if they give 110 euros, that's wasted money because it doesn't go back to them. Yet they failed on average. And another interesting observation is that they still tried, even in these 2 treatments, even in this one where actually you're much better off not contributing, they gave more than half of the group endowment. So, but it is clear that they weren't going to get there. So there's a lot of, there seemed to be quite heterogeneous behavior, and there seemed to be both stubborn cooperators, stubborn defectors, and probably some conditional cooperators in between that were not motivated enough because not enough other players invested in the public good. Other questions? All right. In order to make it a little bit more realistic and include important aspects of real negotiations, some colleagues and I revisited this kind of games by introducing different features and amending what are weaknesses of the original Milinski design. So I'll talk about 2 experiments. In one, the main innovation is to introduce heterogeneity of endowments. We've talked already in class in previous lectures about how, especially having seen the ultimatum game and how important for our actions are the payoffs of others as well. In climate change, this is very much salient in climate negotiations. There's a lot of opposition from less developed nations to invest as much as more developed ones on the grounds that they should be entitled to have a stake in the climate commons and first develop the way that the US and the EU have done in the past. So to do that, we introduced both players of the high endowment, or let's call them rich, versus low endowment ones. We also wanted to bring in this idea of different carbon burdens, so you will see how this was implemented, more or less responsibility, with the rich being the more responsible and the poor being less responsible. And then, given that this is a coordination game because of the threshold, we thought it would be important to introduce communication in a very structured way in order to control and understand what was going on, in the form of pledges, which is very much in line with what happens in the climate negotiations, especially since Paris Agreement onwards. So players had 2 opportunities over the time of these 10 rounds to signal what they intended to do in future rounds. So that's a pledge. The other game that we will see after this one instead focus on the level of uncertainty around that climate threshold, that 120 euros. Because in reality, it could be either for scientific uncertainty reasons or due to social uncertainty, in the sense of, okay, maybe we agree that we need to get to 2 degrees Celsius, but even so, what are the actions that are required to deliver? So we introduce both known but uncertain distribution about the location of the threshold, and ambiguity. So even, and you will remember from the early lectures what this is about, having an unknown distribution. You don't actually know the number of balls, for instance, in each urn. In this case, you don't know of the all possible thresholds, say 120, 140. You don't know exactly which one is more likely. Again, with the ability to signal via communication in the form of pledges. So let's look at the game featuring inequality first. In a way, it's very similar, same stakes. They start all 6 with 40 euros, but there were 3 inactive rounds where basically what became the poor players were forced to contribute 4 in each of those rounds, while the rich players were forced to not contribute anything. So that's a bit like developing in the past, say in Europe, at the expense of the environment. So you gain money, but you have an impact on the carbon burden. So in order to have a control treatment with the symmetric situations, instead in those 3 inactive rounds, everyone, all 6 players, were forced to contribute 2. So they start from the same trajectory, which is basically you're still on target if at round 4 everyone gives 2 on average to get to 120, right? Because we forced, in fact, it's a little bit simpler than in the previous game, because they already started in the symmetric one with giving 6 euros per round for 3 rounds. Again, if you're below the threshold, there's a probability of disaster. That's 50%. The equilibria are 2, also for this game. Selfish thing. You don't even try and just gamble on the climate commons, hoping that you get lucky with 50%. Because of 50%, given that you have already invested 6 euros in the 3 initial rounds where you're forced to contribute 3, on average you will get 17 euros by doing the selfish Nash, right? That's 50% of 4 euros. If you were instead to contribute, it only makes sense if you assume that the other 5. In that case, you could save the planet with certainty and go with the certain 20 euros. Notice that also there's a difference between this 20 euros and this one, because this one is in expected terms, but it depends on the toss of the coin at the end. You may also go home empty-handed if you're in the unlucky runaway climate change scenario. Well, if you get to 20, you save the simulated climate change for certain. So you see, it's a tricky situation. You have both options, but it really depends on what you expect the others will do. So the question is whether countries can coordinate on the better equilibrium where climate protection is provided. So let's look at success rate in these treatments. Let me show you what the treatments are. The bottom 2 are the symmetric ones, right? You have 3 rounds where everyone gives 2, and then they are let to play. We wanted to show the importance of communication, which wasn't present in the original game. So we had both one where we didn't let them communicate and one where they could make these pledges. And the top 2 are identical in the sense that, again, without and with pledge, but for the rich and poor treatment. So 3 rich and 3 poor, which you may expect makes things a bit more complicated, as it does in the real negotiations. because it's so less clear what is the right amount. Right? Before, 2 seemed to be unequivocally the fair choice, but here surely the poor have different ideas about how much they should contribute, given that they have already given €4 per round in 3 treatments. But likewise, perhaps also the rich might have self-serving biases in the sense that they might expect that they are not asked to compensate the poor. So you can read it again in terms of success rate. So this is how many groups managed to avoid the disaster. You see that half of the groups managed. This is the amount they gave, so they coordinated quite well, right? Just above the threshold. This is the standard error. Notice that this is the 5 groups that didn't get to the threshold. And interestingly, they still gave quite a lot, right? €70. So they tried, they were obviously not getting there, but they continue to invest. This is without communication. If you give these people, not the same, but other groups that are equivalent, but they had the option to communicate, you see cooperation level goes up. We have 70% success. And you see they're coordinating very well. You also have miscoordination among the unsuccessful, although they seem to be closer to the selfish mode. They give less, they give about €62. Now, the 2 top treatments are the ones that are particularly interesting, I would say, because they're closest to the real negotiations, because of the inequality, right? The fact that we need cooperation for both developed and developing nations. You see that without communication, it's not very good. Only 2 out of 10 groups succeeded. Interestingly, the unsuccessful ones, they still tried hard. They almost gave €100. That's the most among all 4 treatments, but still insufficient. So there's a lot of miscoordination. Again, as we were not surprised, this is largely due to the fact that they were not allowed to communicate, or at least to send signals, even if it's chipped out, non-binding messages. And then for those that had the option to communicate, you see here the success rate, if you compare it with only 20%, goes up to 60%. That's almost as high as in the symmetric treatment. So it seems that especially in the face of inequality, communication is key. So to summarize the coordination obstacles, inequality reduces provision success, especially without communication. And coordination can be difficult if players disagree about fairness. Now this you don't see from this data, but we asked with ex post survey questionnaires to the participants what they thought was the fair level of investment in the public good, and there's evidence that there were in fact self-serving biases. So the rich tended to focus on the 7 active rounds, saying we should focus on those, that's the future, we should all give €2, while the poor, rightly so, they said, well, we have already done a big part in the past by abstaining to pollute or pump CO2 into the atmosphere, so now the biggest contribution should come from the wealthy. And that unfortunately led to a lot of miscoordination. Any questions, comments? People at home, are you still there? Okay. Was that a question or just a sign of being still alive? All right, so let's see how inequality was handled. So here we focus on the treatments with inequality only. And we have on the left-hand side the failing group, the successful groups, and on the right-hand side you see the ones that didn't reach the threshold. So if you look at the share contributed by each type of player, the rich and the poor, you see that in the end, by the end of the 10th round, they gave more or less the same. What does it mean? That in the active rounds, the rich probably contributed quite a bit more than the poor. And that maybe about €3 on average per round. so that in the end they went home with the same amount of money. But that did not happen to the same extent with the failing groups, in which you have about 60% of the wealth being in, not of the wealth, of the contributions being shouldered by the poor, and only 40% by the rich. That meant that even if the rich in the active rounds did invest a bit more than the poor, that was not enough. Notice that on average in all these groups that failed, they still gave 93. So they still tried, but there was not enough effort by the rich. Now, you might be wondering about the role of these pledges, because we have seen they are just cheap talk, they're non-binding. So let's look more closely. So as I said, there were two opportunities to make these pledges. At the very beginning of the active round, so that's before round 4, right? Because remember the first 3 rounds were inactive. And then again at the start of round 8, so before the last 3 rounds. So here on the x-axis we have the contributions in the active round, and on the y-axis how much they pledged. If you are on the bisectors, the 45-degree line, that would be truth-telling, right? So they pledged, say, that they would give 10, and they actually gave more or less 10. And we see there's quite a bit of that, especially for successful groups. Although you see there's some dispersion, some people pledged low and actually contribute more. As many, probably more, pledged higher than they actually contributed, but there isn't a clear pattern. There seem to be clustered, most of the observations are clustered around the 45-degree line. However, for failing groups, there seems to be a much clearer pattern where pledges are definitely, on average, with some exceptions, higher, right? So here, there was some strategic manipulation of the pledges, and people say, yeah, I will contribute say even 20, but then in reality they contributed around 5. So that caused a lot of miscoordination. That was for the first pledge. What about the second one? So here they have gained quite a bit of knowledge about each other over the first 7 rounds, of which 4 active, 3 inactive. You see, successful groups still stick more or less to the pledges, and they tend to be clustered around the 45-degree line. Here, there seems to be even more of a pattern of pledging high and giving low, or just giving up and pledging 0 and actually giving 0. So these are playing the selfish equilibrium at this point. Of course, you still have some that are more or less on the 45-degree line, or some that are actually even more generous than they state, which doesn't seem necessarily to be a very good idea either, but you see there's widespread mis-pledging with respect to contributions. Questions? So let's summarize what we have learned from this inequality game. Communication is crucial. We have seen that it led, especially under inequality, for an increase from 20 to 60% in success. Cooperation can be difficult, especially if players have different views about fairness. Successful groups eliminated inequality, while failing groups did not. We saw that with the donut charts. Rich and poor players tend to have different fairness perception. That's the self-serving bias that I mentioned, although I haven't showed you the data. Of course, this is a very simple game, so it still doesn't capture many interesting and real of dangerous climate change. For instance, there's no gradual climate change damage arising from emissions in this game. The threshold is known for certain, and it's fixed to 120 euros. There's also a known probability of catastrophe, that's at 50%. Of course, there's only one kind of inequality, or 2 at most, relating to wealth and responsibility, but you can also imagine that people are also unequally vulnerable to climate change. If you are a low-lying island state, you are likely to suffer much more than an inland country, especially in the northern part of the hemisphere. And we have also seen that coordination is easier than cooperation as the one we see in PD games. Okay, questions, comments? If not, let's take 15 minutes break before we come back for the presentations.
Scusi, prof.
Dica.
Sono un membro del gruppo 1. Volevo chiederle se quindi le slide le presenta lei oppure le dobbiamo mettere noi.
Allora, lei è l'unica online?
No, tutti i miei compagni sono online.
Ok, allora facciamo, io credo di poter darvi il diritto di, scusi, adesso sto provando una cosa, se no lo faccio io, ma per semplificare, vediamo se funziona. Nostra partecipanti, comincia lei?
Sì, le posso condividere io.
Imposta come relatore. Ecco qua.
Ok, adesso mi dà la possibilità di farlo.
Esatto, adesso intanto io do i diritti anche a Giuseppe e a Lisa, in modo che se poi lo vogliono fare direttamente loro. Ok, avete tutti e tre il privilegio di condividere, per cui questo dovrebbe semplificare le cose. Intanto, già che ci sono, lo do anche agli altri.
Ma questo lo
Un secondo. Va bene, allora lei sta condividendo?
Sì, esatto.
Perfetto, per cui everyone on Teams sees the slides. Good. Okay. Let me just start the recording. By the way, there was a problem again with Panopto, so I'm afraid the recording for the first part didn't work out. At least we get these all-important presentations. Okay, the floor is yours. Go ahead.
Good morning, my name is Lisa, and with my colleagues Benedetta and Giuseppe are going to present you a case titled Predicting Social Tipping and Norm Changing Control Experiment. The case has the objective to analyze the ability to predict when societies will replace one social norm for another, especially when norms are detrimental, having a significant impact for them. It also examines the evidence from a large-scale laboratory experiment designed to test the theoretical prediction of a social tipping model. The laboratory environment allows to ensure that these conditions are satisfied and applied equally to all individuals. Norms can be very powerful if they are coupled to gossiping and ostracism. The social norm can change over time, spontaneously or due to policy, which aim to abandon the norm, especially detrimental ones. Many of us make a decision consistently to the social norm. If we perceive that the decision we share by the other, will be more keen to make the same decision. As we have seen in regards to the public good, when the game is repeated and the individuals have the possibility to get some information about the level of coordination, it will adjust its preferences according to the behavior of the others. However, sometimes people can misperceive the amount of people sharing that norms. So we are interested to know under what conditions the change in societal preference will lead to behavioral changes in societies and under what condition detrimental norms will persist. The experiment was conducted at the Economics Laboratory of the University of California, San Diego, and the main aspects of the study were explained to the subject at the start of the experiment. A total of 54 sessions were run with 1,020 subjects. The game was designed around three properties. The first states that a social norm must exist before it can be abandoned. The second indicates that there must be a pressure to conform to the norm, such that the cost of deviating is larger than for instigator of change. Higher the pressure to conform, higher the cost to deviate. The last property regards societal preferences, which must evolve over time, creating an impetus for change. Individuals are divided into societies of two people over multiple periods, and they has to choose between two option alternatives, or green or blue, simultaneously and without communicating one to each other. The social tipping game is composed by three situations. The initial one, where all subjects are induced to prefer color, that is blue, which is the social norm. So they obtain the higher reward by coordinating on blue. There is a transition situation. According to the initial assumption, there has been a societal preference change, supposing that this change is caused by an arise of new information, so it is spontaneous. So in this case, one individual prefers green and the other blue. The individual which prefers greens get a higher reward if it is choose green, and the other obtain a higher reward if it prefers blue. So there is, however, a cost of miscoordination, which depends on a penalty parameter that is called P, which is multiplied by the proportion of people choosing green, because blue is still a social norm. So there is a cost for those who are the instigator of the change, but also a cost for those which still choose blue. After a number of periods, everyone prefers green due to a preference switch. Individuals will receive a higher payoff when coordinating on green. The blue behavior therefore becomes detrimental in the sense that societies would benefit from the change. This is consistent with situation in which a certain behavior was considered desirable when it first emerged, but by today's standards seem to be undesirable. The emergence of green as a norm, however, may be hindered by the disproportionate cost suffered by instigator of change in the history of adherence to the blue norm, which affect individual expectation. As underlined before, there is a pressure to conform to a social norm, which can be given by the social image or because the person has interiorized the norm. So if the cost of contrasting this pressure is too high, even for the instigator of change, there will be very high cost for instigator of change.
So the spontaneous change in the societal preference can be described through a mathematical model which involves tipping points. The tipping point in this case corresponds to the proportion of others in the society that previously deviated from it. So the question which arises is, what is the critical number of individuals that must deviate from a norm before that the entire society will deviate from it? So what is the social tipping threshold? The threshold corresponds to the point at which the cost and the benefit from deviating the norm are equal. So basically, for an individual which prefers green, the benefit from choosing green are given by VH minus the miscoordination cost, and the cost from choosing green in terms of cost opportunity are the benefit from choosing blue, so VL minus the miscoordination cost. However, the willingness to deviate from a norm depends also on an individual specific preference, which is the individual specific preference for change. That can be interpreted as the attitude of the individual against conformity, or basically is belief of how much his preference will influence the other. In this experiment, the individual specific preference for change is indicated as represented by a normal random variable, gamma e. So basically, Mathematically speaking, the perceived utility from choosing green corresponds to the benefit from choosing green plus the individual specific preference for change multiplied by V, which is the difference between the H and the I. So by equating the perceived utility from choosing green to the cost from choosing green and solving it for G, we can obtain a mathematical formula for the threshold of that specific individual. We can see that clearly lower the threshold, sooner the individual will deviate from the norm. So for very large value of gamma E, the threshold will be negative, indicating that the individual is willing to be the force that deviates from the weight, so it's willing to be an instigator of change. Otherwise, for negative value of gamma E, the threshold will be very high and positive, indicating the so-called status quo bias. So that basically this individual will persist in choosing blue, even if there is a high proportion of individuals that deviate from the norm. So, given a distribution of threshold, if we consider that in the period T, the proportion of individuals that deviate from the norm is G, in the following period, all those individuals which have a threshold lower than GT will abandon. So, when the society reaches a tipping threshold, the society reaches a tipping threshold when basically the proportion of individuals that deviate from the norm is large enough such that also those which have an individual specific preference gamma I equal to 0, so that basically are indifferent between choosing blue or choosing green, will deviate from the norm, so will follow this. So we can see that the formula of the social tipping threshold is quite similar to the previous one, so to those of the one of the individual, but in this case the term gamma I is missing because basically is equal to 0. So we consider the probability of social tipping as a function of the tipping threshold. If the probability associated with the social tipping threshold is 100%, then there will be a norm abandonment. Otherwise, when the probability associated with the tipping threshold is lower than 100%, the society is locked in the so-called conformity trap, meaning that the society reach the social tipping threshold, but there still be a proportion of the individual that persist in choosing blue. So basically, we can imagine that those which have a gamma I that is negative have a threshold which is very high and is higher than the social tipping threshold. So in this case, the society failed to coordinate on green, and the social norm is not abandoned. So how we can intervene to change the likelihood of tipping change? Basically, in this case, there are three kinds of intervention. The first one involves varying the tipping points. As we can see in the baseline condition, the threshold is 42%, and it is too high because in all the society there isn't a norm abandonment. But if we intervene by introducing an higher reward, like in this condition, or reducing the penalty cost, like in these two conditions, we can see that the threshold will be lower, in this case 30%, and in this 23%, and in the majority of the case there is a norm abandonment. The second kind of intervention concerns influencing the individual specific expectation by considering small society or by introducing public awareness, preference poll, and fast feedbacks. So these are all methods to that aim to give to the individuals the opportunity to know or have an idea of what is the proportion of individuals that have deviated from the norm. The third option concerns introducing an incentive for the instigator, so basically offering a higher reward to those that have a negative threshold.
Here, we can move on to analyze the effectiveness of intervention. Clearly, they have led to different results. While the first two interventions have shown a huge increase in terms of gamma I relative to the baseline condition, we can say the same for the other two, which were less effective at altering expectations. Change was more likely in smaller societies, but not when they received accelerated feedback about others' behavior. This is underlined by the implied increase in gamma. This is smaller in these conditions, like only 39% in fast feedback, and it is worth noting that small society yielded the lowest average earning of all conditions. Data from rapid feedbacks suggest that this way can discourage instigators of change by quickly informing them that most others adhere to the existing norm. In the next slide, we have two graphs. Graph A shows that this okay.
Yes, l'ho cambiato, ma...
Okay. Graph A shows that these are interventions that help society coordinate expectations. The bars show the probability of deviating from the norm in the last 5 periods. P-values are from linear panel regression with the society clustered CES, in which the comparison is with TT43. In all these conditions, the tipping threshold is identical to it, 43%, showing that expectations are a crucial determinant of change. The other graph shows us the average marginal effect in percentage point on the probability of deviation from the norm when the tipping threshold has not been reached. Only individuals who have already experienced a preference switch are included, of course, as obviously individuals who prefer the status quo rarely attempt to instigate change. Next, we turn our attention to individual behavior. In graph B, we have seen a negative coefficient for the tipping threshold, which shows that individuals are on average more likely to deviate from the norm if such deviations are less costly. Although the experiment does not allow us to establish a causal link with the behavior. Both measures are found to be highly correlated with one's willingness to deviate from blue in the experiment. Condition incentive for instigators generated more deviation from the norm and led to the formation of group of instigators in all experimental societies. However, only 3 out of 6 societies eventually crossed the tipping threshold. This demonstrates that incentives may motivate early instigators of change, but neglects the people with a slightly lower willingness to abandon a norm. So the large majority of change instigators, even when change occurred, would have earned more if everyone chose blue in all periods. Thus, instigators of change might have been motivated by a personal preference for social tipping. All this evidence indicates that incurring large nonconformity cost causes individuals to adjust upwards their switching thresholds, which could be attributed to them negatively, updating their expectations about the prospect of change. This is in the last slide, to conclude, linked to what has been said so far, highlighted some several avenues for future research suggested by this study. We think that an important aspect of an experiment is its reliability and the possibility to use some insight to understand how individuals can change their preference. Their findings indicate that the benefit-cost ratio of norm change is a key determinant of the probability of social tipping. In addition, the experiment has provided clear evidence that societies can fail to abandon norms when they become inefficient without policy interventions. The insights obtained have broad implications for predicting tipping in other social settings. This analysis underscores how their model and experimental game can be used for understanding social change broadly. Identifying such a model seems to be vital at a time in which there are mounting calls for social change internationally, and norm change is considered by many to be essential for addressing critical global challenges, such as, of course, first of all, climate change. We have finished. Thank you for your attention. If someone has some question, we will be pleased to answer. Prof, you have the microphone off.
Thank you. I was just thanking the 3 of you for your intervention and nice presentation, and asking whether people either on Teams or in class have questions to the other speakers. Yeah?
Something about the introduction of incentives for the investigators, because I would like to know if they are only successful to get a norm abandonment or not.
if the instigators are always successful to instigate the norm abandonment, correct? Okay. Could you hear the question, any of the speakers? The role of instigators in promoting change, were they always successful in doing so? The question is to one of the three of you, so feel free to choose who wants to answer. And unmute yourself as well.
Sorry, I have lost my connection one moment. So, can you repeat the question one moment?
Benedetta, the question, if you couldn't hear, was about the role of instigators in promoting change. Are they always successful in instigating change or not?
Okay. Yes. If no one wants to answer it, I will answer it. If it's not a problem.
Yeah.
Okay. So basically, as we have seen, this is one of the three options to change the likelihood of tipping, but it is not so effective, because the problem is that when the individual perceives that the instigator of change receives an higher reward, I think that is something like inequality aversion experiments. They will think that basically they are paid to change, so that they change for something that is an egoistical interest and not for the good of the society. And so then for this reason, I believe that the deviation lost some legitimacy, and for this reason, the proportion of individuals that at first is not so willing to deviate will be less willing to deviate. So I think that it is.
Thank you.
The answer.
So there was some evidence of crowding out, right? By giving incentives to the instigators, this was perceived maybe by others as selfish rather than a genuine change. I think it makes sense. Any other questions here, Irimini, or from your remotely connected people? If not, yeah.
I didn't understand what the probability of reaching a tipping point depends on.
Okay, so the question is, what does the probability of reaching the tipping point depend on? What are the drivers of that probability? Giuseppe or Lisa?
Can I take it if Benedetta and Giuseppe agree? Basically, in this experiment, the probability of tipping corresponds to the mean proportion of individuals who abandon the norm. So, the paper say that it is obtained by simulating dynamics over 10,000 trials. So, the mean of proportion that deviate from the norm when social tipping is reached.
Okay, let me see if I understand. So it's based on simulations that were done after the experiment took place and were calibrated on the parameters from the lab experiment. Is that correct?
Yes.
Okay, so that's how they did it. I think it's 10,000 simulations or so, probably Monte Carlo, because of course in order to generate a probability distribution you need many trials and you cannot do thousands of trials in the lab. So it's a mix of simulations and lab results. My question was also on something which is related to that, and especially in the last part of the slides, I saw one that mentioned was it gamma I increasing 300%? Maybe you can share the slides again, and if you just can interpret what that means in actual terms.
Okay. I think it's to a slide. No? The 12.
Yeah.
My first one slide. Okay, this one. Yes. Yeah, this percentage explain how fast and in proportion of the baseline condition the society change her behavior. In fact, the last two have a lower percentage, like in small society, I think 80%, and the last one 59%. So with the first one, that is like 258%, is a huge difference, and it is underline how fast and effectiveness of the intervention is in the society.
So does it mean, for instance, that in the preference poll treatment, they abandon the norm 2.5 times faster than in the baseline condition?
It's not so direct. It's like a prevision is the change in behavior, not is like in the baseline condition, just one change behavior, and in this new condition, like 3 people change behavior. It's like the attitude is more likely, yeah.
Okay, the probability. Okay, good. We're out of time. Thank you, Group 1, Paper 1. A round of applause. Great success. And now the expectations on player 2 are very high, given this stellar performance. So you guys are here, all of you?
Yes.
Okay, so do you want to come to the front? And you have the USB stick or perfetto. Benissimo. Allora, vediamo. Ovviamente non... Facciamo un ultimo tentativo. Vabbè, facciamo così, non lo vedo. Sì. Esatto, sì, può usare o il mouse o la tastiera.
Grazie. No, aspetta.
Floor is yours.
Okay, so hello everyone, we are here to present paper 2, which is about social and behavioral economics. And our starting point is this question, so is image everything? So throughout the paper, we had the possibility to analyze that our social interaction are actually driven by social image concern that keeps reshaping our behavior in everyday life. Of course, there are some kind of behavior that people want to show others, while instead there are some other kind of behavior that people try to hide from others. So, for example, types of behavior like being rich or successful are behaviors that people want to show others, while being like nerd or wimp are behavior that people want to hide. So actually, we've understood that social image concerns is linked with social pressure. So this is the main reason why people want to shape their behavior and to show people some kind of behavior instead of others. But if something is known about social image concern, as we are going to analyze, much less is known about social pressure, and so what is beneath social pressure. And we understood that actually these social image concerns can be analyzed in every kind of situation, as we will give some example, like for example the voting system or the education environment, and has been analyzed through field experiments in all kind of population, from big cities, population of the developed world, to small villages in the developing world. So actually, we decided to start with this formula to give an analytical framework that allows us to understand all the examples that we are going to do. So first, the framework is the following. So we have the individual I and the reference group J in the population. And we have two types of behavior. The first one is type H and the second is type L. Type H is, in this framework, considered as the socially desirable type, so high type, while type L is the low type, so the socially undesirable type. So in this formula, social image that is on the left side of the equality, the social image that individual I wants to give to individual J, to reference group J, is equal to lambda ij, which is actually how much individual I cares about being perceived by reference group J as type H. Actually, we can have that the formula becomes all zero if this lambda is equal to zero, so individual I does not care at all about social image. If it is greater than zero, then in that case, individual I is a conformist because he will care that reference group will think of him or her to be of type H, while if it is less than zero, it is not, individual I will not be a conformist, but we prefer others to not think of them as type H. This lambda multiply I's expectation of what is socially desirable in society, that is WB, so for reference group J, of course, and in this framework is type H, that multiply, again, the probability that individual I is perceived as behaving in a socially desirable behavior, so type H, by reference group J, given the action that is performing. So the examples that we are going to do, starting from the voting system, are examples in which we will understand which are the socially desirable behavior in every kind of situation. Of course, what is socially desirable change according to the group we are in. Individual may be part of more than one group, so sometimes they succeed in doing a trade-off between groups. Some other times they want to hide some kinds of behavior from a group that does not consider that kind of behavior as socially desirable. And so, like, for example, in the voting case, the socially desirable behavior is the one to go to vote, because in this case, individuals will actually consider voting as a duty that they are like doing for the society. So individuals want to be seen as someone that join and participate actively in social life and in the society. So in this case, field experiment has shown that individuals go to vote mostly because they want others to see them going to vote, or just they want to tell others that they went voting. Another example that we've analyzed is education. In this case, we do not have a specific, unique socially desirable behavior or type, because it depends on the group we are in. Like, for example, we've analyzed the white testing. So in this case, low income and minority groups prefer not to be like good at school, not taking good grades, because they belong to a group that does not consider this kind of characteristic as socially desirable, while other white individuals that in most of the schools that in field experiment and in the paper have been analyzed actually prefer studiousness over most of other characteristics in school. So this is in this case for them the socially desirable attitude. Then we have the other case that is charitable giving. Here, we can think that in general people want to donate for a good cause, but most of the cases that have been analyzed in the experiment show that people want to donate just because they can tell others or they can show off what is considered as a like altruism, that is like an important attribute in most of the societies that have been analyzed. And to conclude, we've analyzed effort in the workplace, and the following is consumption and financial investment, that actually are the two, in my opinion, the most important field in which we can really understand why people are concerned about social image, because in the workplace, even if sometimes people are driven by personal recognition and achievement, but most of the time they want just to show others that they are better than them. And like in some field experiment, working close to a certain worker who is more productive drives also others to be more productive, to show a board of directors or manager their efforts and results. And this has been analyzed when there is at stake an award or a recognition without that is not a paid award or recognition, and this shows really the concerns just for social image that has really no pay at the end. And then we have consumption and financial investment. Here, most of field experiment in low-income groups of individuals has shown that even if they have no actual rich or successful state in society, they tend to buy expensive goods like cars or jewelries that can express their success even if they don't have really that success in society, just to show off. And one experiment that caught our eyes was one with platinum cards that do not give incentives or benefit to people that have or possess this kind of card, but everyone wants to have them because it's just like a status, a symbol of success in the society. Now I'll give the floor to Ilaria, who will explain better what is social pressure and the mechanism beneath it.
Okay, so an important thing to do is understand why we change our behavior when we are observed by others. Like for example, some studies analyze the case of education, where students might not want to undertake educational investments, and they analyzed schools where there were low minority, high income share school, and higher minority, lower income share school. And they found two underlying social pressure mechanisms. A mechanism where effort is stigmatized, so it's in the model of acting white, as Federica explained before, and a second mechanism where ability is stigmatized, so being a lower economic type is stigmatized. And in this case, students might not want to sign up for an SAT, for example, prep course, just because they don't want their peers to understand about their economic status. So as we can see, social pressure have effect on us, but it can also have a good effect on people. For example, if students are surrounded by honors peers, it can actually help them in investing more in their education. And then, so as individuals in society, we all have a self-image and a social image, and it's really important to differentiate between the two. An example to explain would be if there was a welfare program where the benefits are high, the costs are low, and the information is widespread, an eligible person would still not want to sign up because they don't want other people to think that they cannot take care of themselves, or maybe because they don't want to admit to themselves that they need help. So in these cases, it's really important to have a broader view of this person, thoughts about self-help, individualism, and the idea of the states being part of someone's life. Because if they have strong opinions on them, they wouldn't sign up even if it was done anonymously, because they want other people to adhere to their high self-image. But there are still some actions that we can undertake to help people engage in good behaviors. Like, for example, when voting or donating blood, stickers can be handed out like they did for the presidential election in the US, and this can actually get more people to undertake these good behaviors, so the participation would be much higher. And yeah, but they need to be symbolic awards and not financial awards, otherwise the behavior would be compromised. Then, as individuals in society, we all we'll interact with other people in different groups, and it's really important to understand what's socially desirable for a person, because that actually it's linked with second-order beliefs. So an example is if in a group of people, someone is against gay rights, for example, a person would think that it's socially desirable to be anti-gay rights, and they will start to act following that belief. So this is also known as pluralistic ignorance, where a person privately rejects a norm, but if they think that it's socially desirable and everyone follows it, they will start to follow that norm too. So some tools to actually correct these second-order beliefs are opinion polling and voting, and also nowadays social media plays an important part in these cases. So our paper was about to understand how social pressure has an impact on our behaviors among different contexts. And thank you all for your attention. And if you have any questions, please feel free to ask.
Thank you. Very well, thanks both. Any questions? Remotely or here? Yep.
So, do you think social media influences people's behaviors?
Well, as I said before, I think that consumption is one of the fields in which actually social image concern can be seen the most. So I think that with social media we can really see it. But as I said before, we can see it with the people buying, I don't know, luxury goods and jewelry and cars. But in our society, it has become like a norm with social media to buy things that are useless. So especially young people through influencers on digital, like on online platform, are driven to buy goods that are like a trend that in general lasts for, I don't know, months or even weeks, and just to make the others see them buy those kind of goods that are like not expensive, as I said before, but in this case just following a trend that is popular. But this actually can increase also for the environmental problems. I don't know, like the production of waste for this, like we can say, fast fashion and trends that have become like increasingly important in young generations.
Very good. Other questions?
Yeah, I have one. With respect to the last part that you are exposed, I was wondering if second-order social beliefs get stronger using social media, in your opinion?
I think it depends, because on social media, they actually shows us what we're most interested in. So there is actually a polarization. But I also think that we can have different sources where we can see what also other opinions would be on the same topic, even if the amount of information is overwhelming sometimes, so it actually takes time as to understand. Yeah.
Good point. Anyone also from Teams? I have a quick question. Based on the paper and the evidence, do you think social or self-image play the biggest factor? Is it, do you have any insights about the relative importance of either?
In general, or
in the studies that you have been
okay.
Based on the paper, and also I think that social image is the one that most concerns people, because also in the example that we've analyzed, in general is the group that drives people acting in a certain way or in another.
Mm-hmm. It's what we portray to society, and we want to feel part of something, and sometimes changing what we truly believe in. So I think social image plays a more important part.
More than the image that we have about ourselves.
Yes. Yeah, because also in the paper there was a difference between private behavior and public behavior that sometimes is totally different, because one person is also driven to go against what she or he thinks, just to follow the group in acting.
Okay, very good. Thank you.
Thank you.
See you tomorrow.
Thank you very much.
Thank you.
Thank you.